Alright, we're going to go ahead and solve linear systems of inequalities. This is the last lesson of the unit. So, here we go. If you remember from inequalities, some of the things are going to be a little different. Now, we're actually solving linear systems of inequalities and not one variable inequality. So this is going to look a little different, and there are going to be some rules. So we got two equations or two inequalities. We're going to go ahead and graph them as if they were equations. So I'm going to go for the first one, which is y is less than x minus 2. So that is in slope-intercept form, which means that negative 2 is my y-intercept. So I'm going to go ahead and draw a point at negative 2. I see that my slope is 1, so that is going to be 1 over 1. So right there, 1 over 1, 1 over 1. Hopefully this is review for you now. Cool. Now, that's a line. That would be an equation. We're talking about inequalities now. And there are going to be a few things that are going to change. So for instance, the inequality symbol doesn't have an equal sign, which means that it's not equal to. So we're going to have a dash line instead of a solid line, which means that any point at that line or any point that is on that line, it's not going to be a solution to the inequality. The second thing that it's going to change is we're going to have a shaded region. All right? So I see that y is less than, which means that I'm going to shade the bottom part of that line, which is going to be this one. Cool. All right. So those are the two differences. You could either have a solid or dashed line, and you're gonna have a shaded region. Now, for the second inequality is y is less than or equal to negative 2x plus 1. So again, let's go ahead and graph it as if it was a regular equation. So my y-intercept is at 1. My slope is going to be negative 2, which means that I'm going to go down 2 over 1. So down 2 over 1, down 2 over 1, and down 2 over 1. Now, because I do have an equal sign, I'm actually going to have a solid line. I'm just going to make a few more points. There we go. Oops. Like that. Cool. So again, I'm going to have a solid line because it says equal. And again, I'm going to have a shaded region. Y is less than or equal to, which means I'm going to shade the bottom part of that equation. So to me, the bottom part is going to be this one. So for previous examples, the solution to a system of equations was the order point x comma y. In this case, we don't have a specific solution. We don't have a point of solution. We actually have a region. So the region is the solution to the system of inequalities. Now, which region is the solution? We're looking for the overlap of those two systems. And I can see that this is not an overlap, so I'm going to erase it. This is not an overlap. Okay. So I see that the overlap of the system of inequalities is right there, which means that any point within that area or on that solid line is going to be a solution. So to give you an example, 1 negative is on that shaded region, so 1 comma negative 3 is 1. of the solutions of that system. And this system has many solutions. So for instance, 0 comma negative 4 is also a solution. Negative 1 comma negative 5 is a solution. 2 comma negative 4 is a solution. 2 comma negative 3 is a solution because it's exactly on that solid line. But what is not a solution? For instance, negative 2 comma negative 1 is outside the area, so it's not a solution. 0 comma negative 2 is on the dash line, which means that it's not a solution either. All right, so hopefully that makes sense. Remember, the solution for a linear system of inequalities is going to be the points under the shaded region.